In the global world, every single industry is going digital. Construction is one of these industries which should be digitalized. However, digitalization in construction industry is a slow-moving process due to its conventional structure. Construction industry consists of separate players who work together to achieve a unique project in a relatively short period. Many of its projects are one-off designs and include labor-intensive activities which are performed outdoor and unstructured working environments. So these in turn make the construction projects highly fragmented and prone to error. Successful completion of construction projects requires a strong collaboration for numerous, multidisciplinary, and sometimes geographically separated project team members. The characteristics of construction industry cause inefficiencies in the processes. Research shows that inefficiencies in coordination, material and labor are consuming up to 30% of construction cost. This added cost is the result of high amount of activities, non-value added activities, such as reworks, defects, overproduction and waiting. So non-value added activities are classified also waste, right? Which absorbs resources such as manpower, equipment and material, but creates no value. The high amount of waste in the construction industry is the result of being one of the least digitized industries. Actually, digitalization process in construction industry has been accelerated in recent times. This has happened due to several reasons. Increased technological capabilities, requirement of better standards, next generation of workers, booming startup environment, supportive policies and legal framework, and also increased market needs, integrated processes, and more importantly, to provide continuous, accurate, and real-time data sharing among project team members from different disciplines. The technologies used in the construction industry include blockchain, Internet of Things, cloud computing, wireless sensor networks, radio frequency identification, building information modeling, artificial intelligence, drones and unmanned aerial vehicles, and also virtual reality, augmented reality, and also mixed reality. Okay, one of the most popular technologies used in the construction industry is the building information modeling, as it boosts productivity, streamlines processes by decreasing non-value added activities, and facilitates data change and interoperability, and accordingly contributes to the successful completion of construction projects. Building information modeling is a 3D representation of building process using intelligent objects, and it provides a collaborative and integrated working environment for multidisciplinary project team members throughout the whole process. National Institute of Building Science defines building information modeling as a product, process, and system. In this definition, product refers to the building information model, which is a structured data set describing a building. A process refers to the building information modeling, which is the act of creating a building information model. And system refers to the business structures of work and communication that improves quality and efficiency. In order to describe the type of information and the way in which that information is presented in building information modeling, its dimensions are used. 3D indicates modeling. 4D refers to the scheduling. 5D points out cost analysis. 6D is for sustainability analysis, and 7D indicates facility management. And currently, health and safety is considered as the 8th dimension of building information modeling. So we are familiar to VR, AR, and MR from Metaverse, right? So we can integrate these technologies to the building information modeling. VR is a simulated experience which employs pose tracking and 3D near-eye displays to give the user an immersive feel of virtual world. It is used in the construction industry for improving safety, training, and design. It is also used for pre-construction planning, for example, designing layouts, and also checking site conditions. The integrated use of VR and building information modeling ensures to decrease costly delays and also change orders. Unlike VR, which creates a totally artificial environment, augmented reality provides users an interactive experience combining real-world and computer-generated content. So augmented reality is the integration of digital information with the user's environment in real time. Okay, it is used in the construction industry for site monitoring and documentation. Integrating AR and building information modeling allows professionals to prevent reworks, facilitates building handovers, and also monitor construction progress. Also, mixed reality blends AR and VR. So mixed reality brings together real world and digital elements. A full building information modeling is not possible without common data environments, which is a central repository where project information is stored. International Organization for Standardization describes common data environment as an agreed source of information for any given project or asset for collecting, managing, and disseminating each information container through a managed process. So it's a single source of information used for sharing, managing, collecting, and collaborating information with project team members. Accordingly, common data environment enables for delivering building information modeling-based construction projects in an efficient and effective manner. So common data environments are cloud-based shared workspaces, including model, document, information in a collaborated and centralized working environment that allows to aid in streamlining and linking processes with their relevant building information in a single shared model throughout the life cycle of the process, and accordingly it allows to a strong collaboration between stakeholders. Common data environment is very important for the data collected from construction sites using radio frequency identification tags and wireless sensor networks, which ensure real-time data acquisition. Radio frequency identification enables objects to be automatically identified through radio waves and information stored on object. Accordingly, that allows to their traceability, monitor their traceability and identification. The integrated use of RFID and building information modeling ensures professionals to streamline material equipment, and information flows in construction projects. On the other hand, wireless sensor networks are small, low-cost device networks which are capable of sensing, data processing, and communicating. So wireless sensor networks are able to collect real-time data from construction sites. So contractors can use wireless sensor networks to monitor the usage of personal protective equipment on site. In addition to RFID and wireless sensor technologies, drones and unmanned aerial vehicles are also used in the construction industry with the aim of inspection and surveying. This technology is also used for site logistics, promotional photography, point cloud, laser scanning, thermal recording and thermal imaging, maintenance and asset surveying, and also supporting building handovers. So all these technologies, RFID, wireless sensor networks, building information modeling, drones, cloud computing, make the Internet of Things possible. So IoT is defined as the network of physical objects, embedded sensors, software, and other technologies for connecting and exchanging data with devices and systems over the Internet. Accordingly, IoT allows to manage and monitor the environment. So, IoT is used in the construction industry for monitoring building energy consumption, indoor air quality, garbage disposal bins or trucks, structural health, concrete curing, location and conditions of materials, equipments, machinery on site, as well as location of workers on site. And also IoT helps to develop real-time site status reports. IoT collects data and artificial intelligence process this data in order to make sense of it. Artificial intelligence leverages machinery and computers to mimic the problem-solving and decision-making capabilities of human mind. Accordingly, AI automates repetitive tasks and empowers decision-making. So, AI is used in the construction industry for supporting construction safety and off-site construction, generative design, and also tracking the real-time interactions of workers, machinery, equipment on site, and alerting supervisors about the potential safety issues, productivity issues, and also construction errors. And also allows to make the construction site more productive, and of course AI is used for addressing labor shortages. Across industries, bringing AI into blockchain technology deliver new opportunities and efficiencies. Blockchain is described as a shared immutable ledger for recording transactions, tracking assets, and building trust. Virtually anything of value can be tracked and traded on a blockchain network. It's a single source of truth, showing all details of transactions end-to-end. Blockchain technology is used in the construction industry for developing smart contracts, which are digital contracts stored on blockchain that are executed when all predetermined terms and conditions are met. So smart contracts are trustful, transparent, and secure as Blockchain transaction records are encrypted and no third party is allowed to involve in this process. In addition, smart contracts are fast, efficient and accurate because there is no need for paperwork and there is no need for additional time spent for correcting errors. Accordingly, smart contracts allow savings because there is no need for intermediaries to handle transactions associated with fees and delays. Accordingly, all these technologies provide numerous benefits, including speed of solutions, simplified design and planning, streamline construction processes by removing non-value-added activities, increase productivity, efficiency, quality, and safety, empower decision-making, enhance data management, allow to easy access to the accurate and trustful information, and also provide better risk management, better workflow and document tracking, accelerate schedule, and of course, at the end, contributes to the successful completion of construction projects. Digitalization in construction process may include some obstacles, right? For example, ineffective data management, reluctant to change, the lack of qualified personnel, lack of management of digital transformation team, lack of awareness of digital transformation, lack of understanding of the process and the steps that should be taken to complete this process, concerns about remote data access, budget increase, IT security, and insufficient standards, outdated methods are some of the obstacles may be faced throughout the digital transformation process in the construction industry. One of the most important solutions to overcome the obstacles to the digitalization is using efficient data management. Another solution could be investing in employee training on information technologies used in the construction industry. Other solutions could be adopting a holistic approach to the entire transformation process, including systems, processes, and people, as well as promoting collaboration, of course getting support from consultants, and increasing digital transformation awareness is very important. Okay, thank you very much.